So first type of word problem that we're going to review is we're going to review the percent mixture problems. So a chemist is mixing some compounds and making a new compound of some type. So let's jump in. A chemist mixes an 11% hydrochloric acid solution with a 6% hydrochloric acid solution. How many milliliters of each solution should the chemist use to make a 600 milliliter solution that is 8% hydrochloric acid? Okay, here's how I set this up last semester, and likely your teacher did as well, is we have one solution that we are mixing with another solution to make a final solution. For each solution, there's two things we need to know. We need to know the concentration, and we need to know the amount. Concentration is always going to be in percent. The amount, it's going to tell us. So in this case, we're talking about milliliters. So our amount will be in milliliters. So we have 6 pieces of information that we need. Okay, so a chemist mixes an 11% solution. So 11% is mixed with 6%. Now, one thing to remind you is you don't want to keep it as a percent. You're going to use a decimal instead. So 11% is a decimal of 0.11. 6% is a decimal of 0.06. Then we need to look at the question that's being asked. How many milliliters of each? So what that tells us is we don't know the amount for either of those two solutions. So it might make sense to start with this is going to be X milliliters and this is going to be Y milliliters. And then how many milliliters of each solution should the chemist use to make a 600 milliliter solution that is 8%? Okay, so we have 8% is our final amount, which is a decimal of 0.08, making 600 milliliters. So that's what we're starting with. Now, the question is, do we really need 2 variables? If we can do it in terms of 1 variable, it's going to be more ideal. So if we take a look at ignoring the concentrations for a minute and just look at the amounts down here. If we take X milliliters and we add it to Y milliliters, it's going to give us 600 milliliters total. So we take X milliliters, we add it to Y milliliters to get 600. So that Y then can be written as 600 minus X. So instead of using Y here, I'm going to use 600 minus X. Now that we have all of that set up, we can finally write our equation. It's always going to be concentration multiplied by amount. So concentration times amount, concentration times amount, concentration times amount. So we get 0.11 multiplied by X, add 0.06 multiplied by 600 minus X equals 0.08 multiplied by 600. Okay, so we have some distributing here to do. So this is 0.11x, add 36, subtract 0.06x, and then 0.08 times 600 gives us 48. So then, combining like terms, 0.11 subtract 0.06 is going to give us 0.05x. If I subtract the 36 over, I'm going to get a 12. So then my x ends up being 240. Now, what's one thing I forgot to do in the beginning that I probably should have done with any word problem? Define the variable. So let's do that and then we'll keep going. We need to define x since that's the variable that we used. You cannot just say x is milliliters. X is 11% solution. Instead, if we're defining x, x is going to be the number of milliliters of the 11% solution.
Are we allowed to say x equals amount of 11%?
Sure, yeah, amount's great. I'm looking for amount and I'm looking for 11% solution. Those are the two things you have to get across in your variable definition. So the reason I want us to do that is so that we know if we actually answered the question. Question is how many milliliters of each solution? So at this point, we have 240 milliliters of the 11% solution. We have not fully answered the question yet. If we substitute, though, that back into y, so we do 600 and we subtract 240, we're going to get 360. For every word problem, I do require that you write a sentence telling me what your answer is. So we're going to say the chemist should use 240 milliliters of 11% solution and 360 milliliters. Oops, I kind of ran out of room. Of the 8% solution. Okay, is this one fairly familiar to us from last semester? Yeah. Questions before we do one more? Okay, here's what I would like you to do then. I would like you, with your group, to do example number 2. So here's what I got. Look at my picture and make sure you have the same setup. Ultimately, the answer should be 8/3. I saw a lot of you express it as a decimal. That's 2.67. If the decimal does not terminate, it doesn't end, I strongly prefer a fraction. So in this case, it's 2.666 forever. I would prefer that you give your answer as a fraction. Because it's a word problem, I'm not going to take off if you give it as decimal, but that's my preference. You do need a sentence, and you need to define your variable. In terms of defining the variable, the two things I'm looking for are somehow you get across the point of amount, either amount or number of gallons, and then somewhere you say pure alcohol. If we remember from last semester, pure alcohol is 100% alcohol. How'd we do on that one? Did it okay?
This is not the test.
This is not on the quiz on Wednesday. No, you have a quiz on Friday that just covers word problems. Okay. Questions for me before we go to the next two? We're going to do the next 2 word problems, then we'll take our break. Is that fair? Okay, so let's move on. The next type we are doing is the type that someone can't remember. I think it was Jamie. The rocket kind. So, a toy rocket is launched from a platform that is 4 feet above the ground. The height h in feet of the rocket t seconds after launch is given by that equation. Okay, so we have this equation. Anytime you are given an equation, it is very important that you know what the variables are. H, we are told, is for height, and t, we are told, is for seconds. So let's see what we can find. A, determine the maximum height of the rocket. How long does it take to reach its maximum? In A, we're being asked 2 things. The maximum height, and then how long. So there's 2 things that we need to find. Anytime you see the word maximum, you're being asked to find the vertex. This is quadratic because that t squared, it opens down because of the negative 16. That's why we have a maximum. Okay, so instead of x this time, it's t. So we do our negative b over 2a, which in this case is negative 160 over 2 times negative 16. Please put that in your calculator to make sure that you put it in correctly. Because a lot of times students have the setup right, but they put it in their calculator wrong. Ultimately, you should get an answer of 5. If you get something else, you put it in the calculator wrong. Anybody get something else? No? Okay, does that 5 answer the question? Determine the maximum height. Is 5 the maximum height? No, what is 5 then? Like in the context of the problem, what does 5 represent?
H.
Not H,
The seconds.
Audrey.
T.
Yeah, it's the time to reach the maximum height. So how long does it take to reach its maximum? That's what we just answered. The time it takes is 5 seconds. So then the question is, if that's t, if that's the time, how do we find the actual maximum height?
Plug into.
Plug t into the equation, yeah. So we're going to get negative 16 times 5 squared, add 160 times 5, add 4. Put all that in your calculator at once. You can do it, as long as you have a graphing calculator, you can do it all at once. So please do that to make sure you get the same answer I do. When you do, I believe you get 404. That's a height, so please put some units on it. Our units in this case are feet. So the maximum height is 404 feet, and that happens at 5 seconds. Please, on a question like this, make sure you understand what you are being asked for. Sometimes it wants the input, sometimes it wants the output, sometimes it wants both. So that's A. B. What is the height? So that tells us we're looking for height of the rocket after 8 seconds. 8 seconds is t. So again, we're just using the equation, this time plugging in an 8 for t. And I believe you should get 260 feet. Okay, and C, how many seconds? That tells us we're looking for time. How many seconds after the rocket launches will it be 100 feet above the ground? If you are asked for time, that means you have to know the height. Whatever you're asked for, you must know the other variable. So that 100 feet above the ground is our h. So using our equation then, we get 100 is equal to negative 16t squared, add 160t, add 4. So the question is, how do I solve something like this?
Quadratic.
Quadratic formula is one option. Charlotte, is that what you were going to say?
Yeah, I was gonna say, but I would factor out first though. Like
We definitely
take out
could.
the
Definitely could take out a GCF. Before we take out a GCF or do the quadratic formula, though, what are we going to need to do?
subtract the 100.
Move the 100 over. So move the 100 over. When you do, you get negative 16t squared, add 160t, subtract 96. I'm lazy, so I'm not going to simplify this at all. I'm just going to jump right into the quadratic formula. Here's my A, here's my B, here's my C. So a quadratic formula then, we get t equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, do not do extra work. There is no need to simplify this before you go to the calculator. We're going to put this in the calculator exactly how it appears, but what do we have to make sure that we include? Parentheses in the denominator and numerator. So I want you to do that. Type it in exactly how it appears. Remember, you're going to have to do it twice, one to add, one to subtract. And make sure the numerator and the denominator are in parentheses. So please do that now. Okay, when I put this in my calculator, I got 0.64 and 9.36 seconds. Because you had to do the addition and the subtraction. Did anyone put this in their calculator and get something different? If you did and you don't want to say it now, tell me later so that we can talk through it. Why are there two answers? Does it make sense for there to be two? Nikolai, why does it make sense for there to be two?
It's the plus or minus.
Okay, in the context of the problem,
Oh.
of what's happening, why does it make sense?
It could be 100 feet when it's going up, and it could be 100 feet when it's going down.
Can you please raise your hand? Thank you. Because there's other people who want to answer, and so then you're just kind of steamrolling right over them. Yes, 100 feet on the way up, 100 feet on the way down. Let's talk about D. How long will it take for the rocket to hit the ground? Okay, so again, how long tells us that we're looking for T. That means we have to know H. Rocket hit the ground. What does that mean about H? 0. Okay, listen real quick before we start solving. What a lot of times people want to do is take their answer from A, 5 seconds, and they double it and get 10 seconds. Because they figure, well, if it takes 5 seconds on the way up, it's going to take 5 seconds on the way down. Can we do that, yes or no? And why? Jamie?
No, because it starts at a height of 4.
Starts at a height of 4. It doesn't start at the ground. If it started at the ground, sure, we could double that 5. But it doesn't start at the ground. So we cannot double. Instead, taking our equation, we get -0 equals -16 t squared. Add 160t, add 4. Again, it's a quadratic. We're going to do the quadratic formula. So I want to give you a minute or two, set up the quadratic formula, and tell me what your two answers are going to be, please. Okay, so we should have gotten 2 answers. How do we know that we should have gotten 2 answers? Quadratic. Remember talking about this t squared? You're going to get 2 answers. So 2 answers I got are -0.025 and then 10.02 seconds. In terms of my expectations, I do expect that you have units. So I expect that you write seconds. And I also expect that you write both answers. Lastly, I expect you to know that the negative answer doesn't make sense. So I do want to see it, but then I want to see you cross it out to acknowledge that that's not the correct answer, or that answer doesn't make sense. Okay. Questions on the rocket one before we do the last problem together? Okay. Can you please read example 4 real quick? So read it to yourself and then we'll start it. Okay. You ready? Okay, so let's jump in. A, find the maximum area of the region so that the animals have maximum space. We're going to have to start by labeling our figure. I'm going to call this side the width and this side the length. Okay, one thing that we did before that's not in this problem, but I want us to be able to do, and so we're going to do it now, is we are going to write this down please, an equation for area in terms of length. So we're going to do that part first before we actually answer part A. Write an equation for the area in terms of length. Okay, so if we start with the labels that we have, we know that area is length times width. When it says write an equation in terms of length, it means all I want in the equation is length. I don't want width. So we need to figure out in our equation how to get rid of width. You with me so far? Okay, piece of information that we have not used yet is we know that we have 180 feet of fencing. So remember that there are actually 3 sides here. There's a width here also. So what that tells us is that if we add the width and the length and the width, we get 180. So that tells us that 2W plus length is 180. Okay, last semester, for those of you who were in math applications, a lot of the times we ended up solving for the wrong variable. So if it says in terms of length, what a lot of people want to do then is they want to solve for length. if we look back at our equation, we said we want to get rid of width. If we want to get rid of width, we need to solve for width then. We need to solve for width. So we get 2w is equal to 180 subtract L. Right? We want to get rid of width, so we have to solve for width. When we divide by 2, we get 90 subtract 1/2 L. All right, so 180 divided by 2 is 90. 1 divided by 2 is 1/2. This, then, is what goes in place of our W. So then in our equation, we get length times 90 minus 1/2 length. And as we can see here, we now have an equation that only has length in it. That only has length in it. So we're going to simplify a little bit. This ends up being 90L subtract 1/2 L squared. This is not in standard form, so I want to put it in standard form. I want to put the L squared first. So we get negative 1/2 L squared add 90L. So
Wouldn't it be L, like, for the W, wouldn't it be 90 minus L over 2?
you can write it as that way. Sure. This is the same. 1/2 L is the same as L over 2.
We could do area is equal to 90L minus L squared over 2.
Okay, again, you're gonna see this, so make sure you have the correct variable. If you do this problem and you solve for the wrong variable and you get down here, then you know you gotta go back and solve for the other one. Just do a little mental check. So that is the starred question. Now actually doing part A, find the maximum area of the region so that the animals have maximum space. Okay, how do we know that this is gonna have a maximum?
There's a negative in front of the 1/2 L, so it's a parabola that opens down.
Parabola opens down. Parabola opens down. So again, anytime you see that word maximum or minimum, it's telling you to find the vertex. So using our equation, our A is negative 1/2, our B is 90. So we get length is negative B over 2 times A. We shouldn't even have to put this in the calculator. This ends up being really nice. We get negative 90 over negative 1, which gives us 90. Now, do a little bit of a mental check. First of all, make sure you have a label, which we do. We have L. Thank you. Is that what we're asked for? No. What is the most efficient way to actually find the area from here if we have the length?
Just plug it back into the equation for W.
Even more efficient than that.
You do 180 minus the length.
So that's what Charlotte just said.
Plug in for area.
Yeah, we have an area formula. If we're looking for area, plug it in to the area formula. Okay, so our area is going to be negative 1/2 90 squared add 90 times 90. So do that now, please, in your calculator. And I believe you get 4,050. Do we? Can anybody confirm? Yeah, Diana, you can. Great, thank you. So that is the answer to part A. That's our maximum area. Part B, what are the dimensions? What are the length and the width? Well, the length we already have. So we would say the length is 90 feet. Again, please provide units. Whole bunch of different options for width. What I'm going to do is use the width formula above that we already came up with. So this width formula. Our width then is 90, subtract 1/2 L, but our L is 90, which gives us a width of 45 feet. again, in part A, it is not even part A, the start question that I asked you. It's incredibly important to be able to write the equation in terms of the variable that I ask you to. Those are our main word problems.